From now on, I will not include this subscript gene, and when we have this X arrow Y, it means X gene is activating Y gene. But in the plot or in the equation, X and Y represent protein. Again, when X is constant, we have this Y protein concentration increases and then reaches a steady state. And now I want to define a response time. And we have this dynamics, or you may say it's Y protein dynamics. And the time it takes to reach half of the steady state. So what I'm saying is this is 100% and this is 50%. This is a steady state level. So the time it takes to reach the 50% of the steady state level can be defined as response time. And basically, response time tells us how fast the protein dynamic reaches the steady state level. So if this response time is long, then we have slow process or slow dynamics. And if that is short, we have fast process. So for example, if we have a dynamics, something like it reaches steady state in this fashion, then what is this response time? This will be the response time. And it's shorter and indicates that our dynamics is faster. Now, P sub xy and Py have a different effect on the steady state and the response time. Let me explain that. Here we have constant x and we have this y dynamic. And let us assume that Py, which is degradation parameter, is constant and the value is, for example, 0.9. For this graph, P sub xy is, say, 0.4. So when we have P sub xy 0.4 and Py 0.9, we may have this graph. Increase this P sub y value to 0.6. What will happen is that we will have increased steady state. And what if you decrease this P sub xy value to 0.2, then we have a decreased steady state. How about the response time? If you look at response time, which is defined as the time it takes to reach the 50% of the steady state level. So this is 100 and let's say this is 50. So if this is 100% and this is 50% and this tau is the response time. What will happen to tau or response time when we change P sub xy value from 0.4 to 0.6 or 0.2? Okay, here we have this 100% steady state for this case. If you find the 50% is about here. And you see that actually the response time does not change. How about this one? Again, we have here about, which is 100%, and the 50% is around here, and the response time does not change. So we see that P xy affects only steady state level and not response time. Now let us fix P sub y value to 0.4 and let us decrease this degradation parameter P sub y from 0.9 to 0.8. And what will happen is this. We will have a decreased steady state level and also decreased response times. So what is the response time? This is 100%, this is 50% for this case. This is the response time tau. And for the blue line, this is 100% and this is 50%, and the response time is this, which is tau for the blue line. So we see that not only the steady state level decreases, but also response time decreases as well. So P sub xy degradation parameter affect both steady state level and response time. So the take-home message is this. Protein production represented by this P sub xy and protein degradation represented by this P sub y are two different mechanisms. Pxy, or the production, affects only the steady state level, while Py, protein degradation, affects both steady state level and response time.